We're going to talk about IP addresses in this video. IP address uniquely identifies a device within a network, especially in a larger networks like internet. We need these kind of unique addresses assigned to each devices in a network in order to communicate with that device. We also have something called MAC address. I'm not going to talk about that. We're just going to focus on IP address here. So we have two versions of IP addresses. We have IPv4 and we also have IPv6. So IPv4 is the version which is predominantly in use now, and IPv4 is slowly being replaced by IPv6, but we are not there yet, and IPv4 is still predominantly used. In most cases, only IPv4 is supported. In some cases, we have both IPv4 and IPv6 supported. Very rarely you'll see support only for IPv6. IPv6 was introduced to solve the IP exhaustion problem. Let's first look at the structure of these two. IPv4 uses 32-bit for address range. Normally, this 32-bit is segmented into 4 8-bit blocks separated by dots. For example, this is one valid IP address and each segment separated by dot is using 8 bits. And when those 8 bits are written as a decimal number, they can range from 0 to 255, which means the total address range is from all zeros to 255.255.255.255. So this is the total address range of IP address. This roughly equates to 4.3 billion IP addresses. And this IP address can also be written in the hexadecimal format. When this is written in hexadecimal format, for each segment separated by dot, we'll have 2 hexadecimal characters, because the total number of bits available for each segment is 8, and for one hexadecimal we'll use 4 bits. So the total number of hexadecimal characters we need for each segment is 2 hexadecimal characters. So for example, 255 will be represented as FF. The whole range written in hexadecimal will look like this. Given that we need to have unique IP addresses for each devices connected to the internet, the 4.3 billion IP addresses is very limiting, because we have a lot more devices connected to the internet than this 4.3 billion IP addresses. So there are different ways in which this problem was solved. One of them is by introducing NAT, which is network address translation. We're not going to talk about that in this video, but predominantly this is one of the techniques used for solving this IP limitation. But this introduces additional layer of complexity and processing, and we needed a better way. So that is why IPv6 was introduced. IPv6 introduced several improvements over the IP protocol, which is using this IP address, and we also increased the number of bits available for the IP address. So currently in IPv4 we only have 32-bit, but with IPv6 we have changed this limit from 32 to 128. So we have 128 bits available for IPv6. This means the total number of IP addresses we have is 2 to the power 128. This is huge address space. So there is also a saying that if you assign one IPv6 IP address to each sand grain in the world, we'll still left with a lot of IPv6 addresses. So it is that huge. We will never have this IP exhaustion issue. And in addition to that, it also introduced some protocol improvements over IPv4. This IPv6 is generally written as 8 16-bit blocks separated by colons. So we'll have 8 16-bit blocks separated by colon. So we'll have blocks like this, 8 of these, and they'll be separated by colon. And each of these blocks will have 16 bits. So we'll have 16-bit separated by colon, another 16-bit, and it goes on like this. We have 8 of such blocks. So this makes up the total 128 bits. Normally IPv6 is written in hexadecimal format. So we'll have something like 1A 2B colon F and something like this. It will go on like this. We'll have 8 such blocks and each blocks will have 16 bits. So this is what IPv6 is. One other thing that I wanted to mention about IP address is that IP address is generally hierarchical, which means we'll have some higher order bits dedicated to identify the network, and then the remaining lower order bits will be used for identifying the host within that network. So this makes it ideal for routing over the internet. or communicating with a device from one network to another network. Okay, we covered what is an IP address, and we also looked at IPv4 range. We talked about the IP exhaustion issue with IPv4, and we talked about one of the solution for that, which is network address translation, and the better solution is IPv6. And finally, we talked about the address range for IPv6. I hope this is useful. Thank you.